Hi everyone. Today we going to discuss A-star algorithm. A-star algorithm is one of the informal search algorithm. We know that there are different types of search algorithms. Uh, they are informal search algorithm and uniform search algorithm. In uniform search algorithm, they have DFS, depth first search, and BFS, breadth first search, and uniform cost. These three are uniform search algorithms, and informal search algorithm A star, greedy, and graph. We know that A star is informal search algorithm. Today we discuss A star search algorithm, one of the informal search algorithm. It is one of the informal search algorithm. We know that which provide the shortest path from start node to goal node. Here is the start node, and here is goal node. This A star algorithm find the shortest path from A to G, whether A, B, C, D, G, A, B, D, G. We don't know which path is shortest. We have to find. For that, we are using cost of the node. Each node have a cost. Here, A to B, they have a cost B, and A to G, the cost 10, like that. This is also denoted by G of n. And mainly, another one is heuristic function. Heuristic function is one of the key to find the A star algorithm path, and it denoted by h of n. Here heuristic function is g. This is heuristic function. Every node have a separate heuristic function. We have to use that heuristic function and cost, and we have to find the path from start node to goal node. And it provides the optimum solution. We know that A star algorithm provide the optimum solution start node to goal node, which path is very shortest. It will find. And we have a formula that f of n is equal to g of n plus h of n. This is the also called as fitness number. This is main key formula to find the path in every node to node. Here f of n is the solution cost which get from g of n plus h of n, and we have to go through thoroughly in a systematic manner. Okay, let me go with one example and we will discuss. Let me go with a problem and the solution of A star algorithm. First, suppose S is a start node, S to A to B, A to C, B to D, and C to D, and D to G, S to G. This is the path. S A C D G, S A C D G, or S A B D G, S to G. We don't know whether which path is right. Okay, let me include B to C also, no problem. We can go with a random G of n and H of n. We take randomly. For suppose S we can take 6, 2, 5, and here C is 3, this is 1, and this is 0. We can take randomly. In exam point of view, they will provide the h of n is in the given data only, but we are taking the randomly and we can find it with h of n. H of n is heuristic function. We do not have to forget. And the cost to reach. Here the cost to reach also we will take randomly. No problem. 1, 2, 5, 6, 9, 0, 5, like that. And here 6. We take randomly, no problem. Here, this is the question we completed. There are two possible to reach G, means goal node. This is goal node. there are two possibles, SA, BC, CD, DG and S2G. There are two possibles. So we will go in a systematic manner. S2A is one possible way. S2G is one of the possible way to get the start node to goal node. Here S2A, we have the formula f of n is equal to g of n plus h of n. F of n is equal to g of n plus h of n. We have the formula. Yes, here f of n is the cost to reach and the addition of g of n and h of n. Here g of n is cost, that is S2A 1 plus, and the heuristic function we have to take the next one of the start node. Here SA means A we have to take. For suppose SAB is the path, means we have to take phi as a heuristic function. SAB means like that. And here the heuristic function is 2. That is 2 plus 1 is equal 3. Okay. And here next case S and G. If the start node is 6 and goal node is 0. That is heuristic function. And J of n, we have to, J of n is 5. 5 plus goal node heuristic function is 0. That is 5. Here, which one is shortest? This one is shortest. Right? And this one is little bit bigger than this. So I have to put this as a hold and we have to continue this path. Okay, one path is over and then this one is hold. We have to put this as a hold. Now, S, A, B. S, A, C. Yeah. We going this path now. From A to there have two possibles, B and C. Here SAB, SAC. And same like f of n, g of n plus h of n. We will directly go with the solution only. Here SAB, 1, 2 means 2 plus 1, 3. 3 plus, and we going this node now. So heuristic function we have to take B, that is 5. That is 5, 6, 7, 8. Okay, and this now here. SAC. 1, 5. 5 plus 1, 6. Plus 5 plus 1, 6. And heuristic function of C is 3. That is 6, 7, 8, 9. So this is 2 bigger than this now. So we have to put this as a hold. And we have to go this route. And now SAC. SAC is holded now. SAB and C, SA, B and D. We have to go in that node. Okay, these two completed now. Now SA, B and C. SA, B and D. Here we directly go, no problem. Here SA means 1, A to B, A to B 2, B to C, B to C 9, 9, 10, 11, 12. J of n is 12 plus, and we are going C now. The heuristic function of C is 3. That is 12 plus 3, 12, 13, 14, 15. And here SABD, SABD. We have to go. J of n is SA1, A2, A to B, mean 2, 2, 3, and B to C, B to D. That means B to D, 6, 6, 7, 8, 9. Here 9 plus, and heuristic function of D is 1, that is 10. If this one is bigger than this now, so if we have to hold this and we have to proceed this. So SABD. SABD. We have two possibles, SABD and G. Sorry, one possible, SABD and G. There is one possible only. So we will go with that. SABD and G. That is G of n. SABD and G. 2, 3, 4, 5, 6, 7, 8, 9, 9, 10, 11, 12, 13, 14, 15. 15 and it is 0. Resting function of G plus 0. That is called 15. Here we will see. This is the path. We have to compare with this resultant value to all olded value. Here 15 here old, so equal. Here 9 and here 5. This is little bit of smaller. So we have given data. According to given data, this is the solution and this is the smallest path. S, A, B, D and G. This is the smallest path according to the given data. In this case, this one is a given data. This one is the solution, but maximum this one is how to low comparing with this holded one. This is 15 now. This is 15 and this is 9. This is 5. So the solution will be less than holded one. We take the given data as a wrong, but because of we are learning now, so given data we taking randomly, so it will get like that. But in real time, this one is lower than this holded one. For suppose this 15 now 5, this resultant will be less than 5 in real time. So we have to go like that. According to given data, we will get this. And this is the shortest path according to given data. This is the procedure we have to learn. Okay. Thank you.